Introducing Ultimate Pathfinding Visualization Toolkit. System Architecture. The application is a sophisticated graph visualization and pathfinding tool built with Python, comprising two main classes. Graph Tool handles graph data structure and algorithmic operations. Graph App manages the user interface and interactions. Initialization process. When the application launches, it creates a blank canvas. Loads a background map image, optional. Sets up a user interface with multiple interactive components. Prepares for graph manipulation and visualization. Node management capabilities. Users can interact with the graph through several key functions. Add nodes, click on the canvas to place nodes. Add edges, connect existing nodes with optional custom weights. Automatically calculates Euclidean distances between nodes if no weight specified. Supports visual representation of nodes and edges on a map background. Pathfinding algorithms implemented. The tool includes 5 sophisticated pathfinding methods. Shortest path finds the most direct route. Dijkstra's algorithm calculates optimal paths with weighted edges. Breadth first search, BFS explores nodes level by level. Depth first search, DFS explores paths as deeply as possible before backtracking. A** search uses a heuristic approach for efficient pathfinding. Visualization features. The application offers rich visualization capabilities. Animates algorithm traversal. Highlights explored nodes and paths. Displays node IDs and edge weights. Supports zooming and scrolling. Provides a step-by-step exploration of pathfinding processes. Graph management tools. Advanced graph handling includes saving graphs to files, loading previously saved graphs, clearing the entire graph, persistent node and edge tracking, user interface components. The UI is designed with multiple interactive elements. Canvas for graph visualization. Control panels for node and graph management. Search algorithm buttons. Status bar for current mode and feedback. Node selection dialogues for pathfinding. Technical technologies. The application leverages Tkinter for GUI development. NetworkX for graph algorithms. Matplotlib for visualization. PIL, Python imaging library, for image processing. Pickle for graph serialization. Error handling and user experience. Robust error management includes warnings for invalid graph operations. Informative message boxes. Graceful handling of missing images or invalid selections. Extensibility and potential applications. The tool is versatile and can be used in various domains. Network routing. Transportation planning. Educational demonstrations. Algorithm learning. Game development pathfinding. Key technical highlights. Object-oriented design. Modular architecture. Interactive visualization. Multiple pathfinding strategies. Flexible graph manipulation. The application represents a comprehensive, user-friendly approach to graph theory visualization and algorithmic exploration, making complex pathfinding concepts accessible and interactive.